In the last video, we discussed the use of dynamic programming in allocating teams. This was for a sales situation where the sales in an area increases with additional resources being deployed, but not linearly. Today, we will discuss an application from a hypothetical research facility. Let us say they have 3 projects going on and the leadership feels that they can reduce the chances of failure by deploying additional scientists. Currently, the probability that all 3 will fail is 19.2%. The probability of success of each project is estimated when 1 or 2 more people can be deployed. Unfortunately, only 2 resources are sanctioned, and therefore they need to prioritize. Like in the earlier case of assigning salesmen to territories, we will first assess how we could optimally allocate the additional scientists between projects A and B. The overall probability of failure is the product of failure of each project individually. If we do nothing, the probability of failure considering projects A and B is 24%. If we have the choice of adding 1 more resource, it is better to assign to project A as it has lower probability of failure. If 2 resources are available, then we either split them between A and B or put them both on B. So far, so good. Now let us see how the situation evolves when C is also in the mix. It seems that the best option, essentially the one that has the lowest probability of failure, is when we assign 1 resource to C and the other between A and B. Since we already know that if we have just 1 person available between A and B, it is better to assign her to A. Therefore, the final allocation is A equals 1, B equals 0, C equals 1, and with this the probability that all 3 projects will fail goes down to just 6%, a significant improvement. Okay, let us assume an additional scientist is now available. The probability of all 3 projects succeeding after 2 additional scientists were deployed, 1 each to A and C, is now 16%. The leadership wants to estimate by how much it would go up if 1 more resource was to be added. The baseline assumption is to add 1 scientist to project B. We will assess if that is the best option. As earlier, we start by assessing scenarios where 1, 2, or 3 resources are available to be shared between A and B. For example, if 1 resource is available, it is better to deploy in B. If there are 3 people available, the optimal allotment would be 1 for A and 2 for B. However, we must also take into consideration project C. When C is assessed against the best of A and B, the optimal allotment turns out to be 2 for C and 1 split between A and B. Therefore, the final allocation is A equals 0, B equals 1, C equals 2. With the additional deployment, the probability that all 3 projects would succeed goes up to 25.2%. That is all for now. In the next video, we will discuss how dynamic programming is used in a manufacturing context.